Good morning students. Today we are going to discuss IIT-JEE NEET Foundation, laws of motion. Laws of motion comes under the mechanics. So laws of motion, there are some concepts which are related to the laws of motion, Newton's laws of motion and inertia. Some conceptual things we are going to discuss today. See, the topics to be covered is Newton's laws of motion and see concepts related to the Newton's laws. See, coming to the first slide, what are the Newton's laws of motion? Sir Isaac Newton discovered the Newton's laws. There are three laws of motion are there: Newton's first law, Newton's second law, Newton's third law. See, what is Newton's first law? Newton's first law states that every body continues to be state of rest or uniform motion unless compelled by an external force. See, if body is at rest, it remains at rest. If body is at motion, it remains at motion unless an external force acts on the body. So, second law, the Newton's second law, there is first law is law of inertia. It is also called a law of inertia. Second law, law of momentum, that is the rate of change of momentum is directly proportional to the applied force, the external force. That is Newton's second law. Newton's third law, for every action there is an equal and opposite reaction. So these are the Newton's laws. The laws of motion were first introduced by the Newton in 1687. They form the basis on the classical mechanics. See, mechanics classifies into classical mechanics and that Newtonian mechanics or classical mechanics, and another one is quantum mechanics or Einstein's mechanics, that is another mechanics. So in the classical mechanics, Newton's laws will come. These laws describes the behavior of the motion of the object. These laws describes the behavior of the motion of the objects and how forces are going to be there. In the laws of motion, the first important definition we should learn about force. What is meant by force? Force is nothing but a push or pull acts on a body which changes or tends to change the state of rest or uniform motion of a body. If a body is there, if you are applying some push or pull, so there is certain change its position, change its state of rest or uniform motion. That we can call it as a force. The unit of force is Newton. SI unit is Newton. The CGS unit is dyne. 1 Newton is 1 kg meter per second square. You know that. See, force is a very, very important term in the laws of motion. See, the force, different types of forces we'll discuss in the next videos. See, here force equal to mass into acceleration. This is the important formula in the Newton's laws of motion. Force equal to mass into acceleration. The unit of force is Newton. Newton in the SI system. So capital N is the symbol for it, and dynes are the CGS system. 1 Newton equal to 10 power 5 dynes. 1 Newton equal to 10 power 5 dynes. So basically the Newton's laws, there are three laws are there. See, the three laws, the Newton's laws. See, Newton's first law, Newton's second law, Newton's third law. See, Newton's first law of motion. What is Newton's first law? I just told you. Every body continues to be state of rest or uniform motion unless compelled by an external force. The same thing, it is also called law of inertia. See, it is known as law of inertia. It states that the object is at rest. It remains at rest. If object is at motion, it remains at motion. It moves, it will continue move in a straight line. See, there is a external force unless acted upon by the external force. So that we will call it as a Newton's first law. This means that the object maintains the state of rest or state of motion unless the force acts on it. For example, if a body is there, so if table is there, the table remains at rest until you apply force on the table. If the table okay, so you want to change its position, you have to apply the force, then only, see here the resist to change the position is what we will call it is inertia. The resist to change its position, or something like the tendency of a body to change its position, is called inertia. Here the first law defines inertia, that's why it is called law of inertia. It is also called law of inertia. So here the first law explains, for example, you are in the moving, so you are in the stationary bus, suddenly the bus started, so you will feel like moving backward, that is due to the inertia only. So the inertia which explains, see, inertia of rest, you are at rest, suddenly the bus is moving, due to that you are changing your position, there is some external force acts on you, try to change, in the process of that you will be feeling moving backward, you have to see, that is due to the inertia only. See, this is about Newton's first law. Newton, once again I am telling you, Newton's first law defines, so every body continues to be state of rest or uniform motion unless compelled by an external force. So coming to the next law, that is, see here the, see, moving bus, Newton's second law, see the Newton's laws, Newton's second law, so Newton's third law. So Newton's second law, the acceleration of a body is directly proportional to force and inversely proportional to mass, or the rate of change of momentum of a body is directly proportional to force. Acceleration is directly proportional to force. The acceleration is directly proportional to force. See, and acceleration is inversely proportional to mass. Acceleration is inversely proportional to mass and directly proportional to force. This is Newton's second law. The rate of change of momentum, the rate of change of momentum is directly proportional to applied external force. See, the momentum is nothing but the mass into velocity. The product of mass and velocity is called momentum. The change of momentum, final momentum minus initial momentum, we will discuss in the next videos more clearly. So Newton's third law of motion, that is for every action there is an equal and opposite reaction. So this Newton's third law exclusively used in the rockets. Okay, so the, see, when rocket is projecting upwards, so there is some, first we have to apply the, see, there is some, the gases which are going to be burnt and which will be coming in the downward direction, rocket moves upward direction. So this is about the Newton's laws and the gases which are escaping from that. So Newton's laws. Coming to the types of inertia, what are the different types of inertias? See, inertia of rest, inertia of motion and inertia of direction. What is inertia? The inability of a body to change its state of rest is called inertia of rest. The inability of a body to change its state of motion is called inertia of motion. The inability of a body to change its direction is called inertia of direction. Or the tendency of a body to change its position like rest, that we will call it as the inertia of rest. The tendency of the object remains at rest, resist to any attempts to change it. So that we will call it as a inertia of rest. Example of inertia of rest, see, a book is lying on a table, it remains at rest until and some force acts on it. Coming to the inertia of motion, the tendency of a body to change its motion, it remains at motion only unless and until there is some attempting of changing its path. So here car is moving at a constant speed, so you want to change its direction, definitely you have to apply the force, some brake force should be applied, then you can change its direction. Inertia of direction, the tendency of a body to change in its direction. See, for example, a car is moving in curvatures, so to change its direction, so there is certain external force is acting on it. So these are all the different, see, there are types of inertia, inertia of rest, inertia of motion and inertia of direction. See next slide, applications of Newton's laws. See what are the different applications. Newton's laws in the vehicle design. So Newton's laws are used designing a vehicle like different like buses and aircrafts and spacecrafts. See, engineers use the laws of inertia and calculate how much the force is required to move this vehicle or how much power is needed. All this comes under this topic only. So to maintain its speed, the aerodynamic design, design we are going to have. So for that type of the vehicle designs, definitely Newton's laws are helpful. Coming to the sports, in the sports also Newton's laws are extensively used like football, soccer, cricket, everywhere. So and tennis, the players use Newton's laws to get the trajectory, what trajectory it is supposed to hit the goal and etc. Those things are in the advantages of the during the game. So we are going to use Newton's laws in the sports also. Coming to the space exploration. See, there is another application, space exploration, like different spacecrafts, rocket propulsions and etc. All these are space missions. So Newton's laws are going to use. See, in the engineering industries like different cement industry or buildings, construction, everywhere. So Newton's laws are extensively used to maintain the structures, big structures, etc. There Newton's laws are used. Coming to medical applications, in the medical equipment design also Newton's laws are going to be used. See, and safety features, in the design of safety features, where how much force, how much load it is acting, what type of energy and all that, whether it is can bear it or not, all those things can be calculated here by using Newton's laws. See, coming to the next, examples of inertia of rest. What are the examples of inertia of rest? Inertia of rest, inertia of rest is nothing but the inability of a body to change its state of rest by itself is called inertia of rest. The examples of inertia of rest is, see, for example, a stationary car is there. You are sitting in a car is parked. Suddenly car started. You are pushing backwards. That is due to inertia of rest. A cup on the table. So if a cup is there on the table, so that remains at rest until and unless and until you are acting some force acts on it. So the pencil in a desk, a pencil, you want to change its position, definitely you have to pick up the pencil and all those things. Books in a shelf and rocks on the ground, all these are the examples of inertia. So inertia of rest. Inertia of motion and direction, they are all there is inertia of motion, the tendency of a body to change its motion by itself, that is inertia of motion. So if a body is moving, so let us say satellite is moving in a circular path, so there is inertia of motion helping to continue the motion in the circular path. See, these once the object is set to be at motion, it remains at motion unless and until some force acts on it. So the examples of inertia of motion, see, when you are moving in a moving bus, suddenly the bus driver has applied the brakes, you will be moving forward. That is due to inertia of motion. You are having a motion, so that will be continued. So there is some external force acts on it, then automatically you are trying to resist the change. That is due to inertia. So a moving car, a spinning top and ball rolling, etc., rocket in the space, all these are due to the inertia of motion only. The inertia of motion and inertia of direction. So these are the examples. So thank you very much. So we'll continue in the next video.